Assalamualaikum, my name is Haina Afrina binti Anwar Shahrin. My matrix number is CN210264, and today I'm going to present a project report along with my group mate. First and foremost, my contribution on this presentation is to know the objective and information that is needed on this project. Next, Farah binti Zaid Hisham is in charge in project scope and conclusion of the project. Nurhanim Syahidah binti Haslan is the one who lead the project and make sure that the project outcomes successfully. And lastly, Nur Sabana binti Su'aib responsible for calculation and make comparison between the result that showed on the circuits and manual calculation. Let me start with the introduction first. The goal of this project is to design and implement a simple yet effective sound detection. An operational OM741 is used in the circuit to recognize and amplify sound signal. This allows for further processing of the sound's existence or absence to trigger other devices. The sound detector, circuits, circuit design, project scope, circuitry and results are covered in this presentation. The following objectives are among the main ones for this project. First is to create a sound detecting circuit based on the OM741 that is capable of accurately and enhancing the sound waves. Second is to build an audible presence indicator using LEDs. And third is to inspect and evaluate the circuit's operation. That's all from me. Thank you.
Okay, Assalamualaikum and hi, my name is Farah Shahira binti Zaid Hisham. So I will explain about project scope. So we got 4 scope here. The first one is function component for simulation. The second one is the function of software. Next, relationship for each component with software, and the last one is project purpose. Okay, for function component for simulation, there are a few types of component that we've been used for our project. The first one is resistor. So basically, resistor is a passive device to control the flow of electric current in the circuit and to offer a particular resistance values as well as split or adjust the voltage. Next is variable resistor. So variable resistor known as a trimmer resistor or potentiometer. So the capacity to adjust resistance within a certain range. Okay, the third one is OM-LM741. So this is to accurately with high strength amplify analog signals. So it has 2 inputs, which are inverting for negative and non-inverting for positive inputs, and it is utilized as a buffer or voltage follower, and it is to contrast to voltage and output a digital result based on how much different they are from one another. So it can be used to build active filters including notch, band pass, low pass and high pass filter. Next, we use OM-LM358. So basically it is to accurately and moderately enhance analog signals, and it is operate as a buffer or voltage follower. It compares the voltage of 2 inputs and provides a digital output determined by the magnitudes of the differences. So it can be used to build simple active filters including low pass, high pass along with band pass filters. Okay, next we use sounder as the output. So it is to generate audible sounds or tones. To verify button pushes validation of input or system status changes generates beeps or tones. The last one is temperature sensor LM35. So it is precisely measure the environment's temperature. Okay, the next scope is function of software. So we've been used Proteus EDA software to run our circuit. Why we use this software? Because it provides a full suite of instruments for constructing electrical circuits, such as schematic recording, PCB layout, and auto routing. Okay, next is the relationship for each component with software. Okay, so the main components to be highlighted in this project are OM LM741 and OM LM358 and temperature sensor LM35. So whereas the LM358 is a twin OM like LM741, although not directly connected with LM35 temperature sensor, those OMs can be used in applications that need temperature detection. So the output voltage of LM35 will be amplified and buffered by the OM when the LM35 is connected to it in this manner. So the voltage that has been amplified can be processed further and utilized to gauge temperatures or control in other parts of the circuit. Okay, therefore it is necessary to simulate the circuit in the Proteus simulation in order to obtain the measure value for comparison with calculated value, and to compute the circuit's voltage and currents value in order to ensure that they match the value that was determined by the software. And the last one is the project purpose. So basically it detects the temperature of overheated gadgets, such as in factories or industry with large equipment, where it is critical to take action if the machine is overheats.
Now I move to the methodology of the projects. Our projects aim to create a sound detecting circuit based on the OM 741 that is capable of accurately and enhancing the sound wave. In order to achieve our objective, we follow the systematic methodology throughout the project. For the group discussion, we initiated the project by conducting a group discussion to brainstorm idea, gather insight, and define the project scope. The discussion helped us establish a clear direction for the project and identify the key aspect to focus on. For the second step, references source, we utilize a various reference source, including internet-based research, lecturer slides, and research paper. Through this source, we gather the relevant information and content necessary for our project. Then for the flowchart creation, based on the insight from the group discussion, we have created the flowchart to visualize the project implementation process. The flowchart included key step, decision point, and dependency to guide our project execution. Next, for the project implementation execution, by following the flowcharts, we proceed the implementing the project according to the defined step. We also utilize the gathered information to create a accurate circuit diagram, ensuring proper functionality. Next, for the research and analysis, we conducted research on various electronic components such as resistor, variable resistor, OM, sounder, and also temperature sensor. We analyzed the function and characteristic of this component to understand the role of the project. For the last step, which is problem solving and troubleshooting. During the circuit simulation phase, we encountered a minor problem and obstacle. After that, through the discussion and analysis, we addresses this challenge and found the appropriate solution to ensure successful implementation. Last but not least, our project methodology involve a group discussion, information gathering, flowchart development, project implementation, research and problem solving. The systematic approach enables us to execute the project efficiently and overcome the challenges. By following the methodology, we successfully achieve our objective. Next, for the circuit design, we use Proteus software to design and simulate the circuit in order to get the possible value during the simulation. For the result discussion, the sounder will make sound if the temperature sensor reach more than 37 degrees Celsius.
I will explain about calculation part, which is for the non-inverting amplifier circuit. We use the formula of non-inverting amplifier and we get the output, which is the voltage output is 10.37 volt and the current output is 1.037 milliampere. The voltage gain we get is 28.03 volt. When we compare the calculation result and the simulation result, it is similarly same to each other value. And we move to the inverting amplifier. So the Vout that we calculate using the inverting amplifier formula is 10 volt for Vout and 1 milliampere for current. The voltage gain is 27.03 volt. The calculation and simulation value is also the same. This is the comparison graph for both output voltage and output current in simulation and calculation value. We can see there it is just slight of different for non-inverting, and for output current it is just the same and no different.
So in conclusion, temperature sensors are frequently built into the overheat detector to keep an eye out for unnatural temperature increases. The sounder is activated by the detector when the temperature crosses a set threshold, producing a powerful auditory signal. So this acts as an urgent warning to inform people and motivate them to take the proper activities, such as looking into the source of the heat, starting fire suppression procedures, or leaving the area. A sounder-based overheat detector is a useful tool used to identify excessive heat and issue an auditory alarm or warning. So this kind of detector is frequently used to ensure or guarantee safety and stop potential fire threats in a variety of applications. And the detector can efficiently alert people nearby to the presence or of excessive temperatures by using a sounder. Nevertheless, by detecting and alerting people to high heat, an overheat detector with a sounder adds a critical layer of protection. So this may improve situational awareness, makes it easier to react quickly, and aids in preventing incidents, damage property, and potential person harm. Thank you. That's all from us.